Good morning, everybody, and welcome to Ask the Pro, Troubleshooting 101. We're going to start with a thank you to the SCA who's sponsoring this program and the CTech B program. The CTech B is for anyone interested in pursuing a career or as a coffee technician and seeking the ability to have industry-wide recognized training. We will post the link for the program in the chat and the questions, and feel free to reach out to us via this website if you have any questions. Caleb Leach will be moderating today. Caleb, turn it over to you.
Thanks, Highland, and welcome everyone to Ask the Pro Season 3, Episode 3, Troubleshooting 101. Welcome to Ask the Pro series.
Coffee.
What?
We forgot to do coffee.
Oh, well, it's going to do our introductions.
Oh, okay.
We should have talked about that. Anyway, I'm going to introduce this episode and do the disclaimer, and then we will introduce the panelists. Highland's very excited this morning, maybe too much coffee, but we'll get there. Just give me a second, Highland. Introduction. So welcome to Ask the Pro series. This is our 3rd season. We're committed to presenting these episodes throughout the year, so save Fridays at 8 for the coffeetech Guild. This presentation is for informal purposes only. The views and opinions expressed in this webcast are those of the presenters and do not necessarily reflect the official policy or position of any aspect of the Specialty Coffee Association or the companies the panelists may represent. Now, on to the meat of it. So I want to introduce our panelists, and what we're going to do is, sorry. I'm having technical difficulties on my side. Can you guys hear me?
Yep.
Yeah.
Okay. Well, does the screen still look good for you guys? Because it got weird for me.
Yes.
We're still in introduction.
Okay, great. Oh, we're still at introduction?
Yeah.
Okay, so that's what's weird is that it didn't forward. Let me see if I can fix it.
Maybe you should call a tech to help you.
You're the person I'm supposed to call, Rachel. All right, guys. Don't know what happened here.
You know, for techs, we should be able to get this right.
Well, I mean,
Oh, there you go.
an espresso machine, I would not have any problems.
You're way down there now. You're not troubleshooting.
Oh, okay. It came back?
It came back.
Yep, it came back.
Okay, how's this? Are we at our panel now?
You're at our panel.
Woo! Hey, see, it just took a minute and reaching out to 4 or 5 people on this panel to figure it out.
That's what this episode's about.
Thanks for all the troubleshooting tips, guys. All right. So I'd like to introduce, first we'll go to Kurt Benedict from Last Man. I'm going to ask each of you to just tell me what you're drinking this morning. Hopefully it's coffee, or what your favorite coffee is, and just do a real brief introduction of who you are. So Kurt, can you start us off, please?
Oh, well, first I've got some coffee that was in the machine today. Not sure what it is. And some seltzer water. Got to have some kind of water to go down with it. But I run and operate a small repair company out in Denver, Colorado, and we have about 4 techs and 1 shop tech, and that's about what we are.
Awesome. Highland?
I am drinking, unfortunately, 2-day-old David Meyer's Campfire Blend, which is kind of become one of my favorite coffees. Also, we need to add that for our viewers, we are recording this episode, just to let you know. I am West Coast Service Manager for Espresso Partners. I run anywhere between 10 to 15 techs, plus I manage our nationwide third-party network.
Awesome. Thanks, Highland. Mark?
I'm Mark with Espresso Tech. This morning I'm still under the weather, so I'm still drinking hot water with lemon. It's a 3-week battle here. I own and operate a regional service repair company in the Midwest, covering about 11 states.
Nice. Thanks, Mark. Rachel?
I am with Lamazoko USA After Sales Service and Support. And I am drinking my usual single origin Guatemalan.
Nice. Matt?
Hello. I work for Vixo. I get to hang out with a whole bunch of techs across North America from all sorts of different companies. So I enjoy being able to communicate with a lot of different people, which a lot of them I actually see on the screen right now. I am currently drinking a local Sonorgas Ethiopia right now. So watched Process Ethiopia. It's quite nice.
Thanks, Matt. And my name is Caleb Leach, Equipment Services Manager with Starbucks. This morning, I'm actually having a Guatemalan from a little local roaster here in Tacoma, where I live, named Bluebeard, and it's delicious. It's one of my faves. All right. So, move this out of the way here. Let's get started. So, one of the most valuable but difficult to learn skills for any technical person is the ability to troubleshoot a system. Troubleshooting means the act of pinpointing and correcting problems in any kind of system. For today's episode, our panel will go over some troubleshooting concepts and practical applications. So I'm going to turn this over to Highland.
So we can all relate to this. This whole troubleshooting comes from an experience I had about 10 years ago as a tech, where I was talking to a tech who was having a fill problem. And I would ask him what he was doing to check it. And I said, well, what did you do? And he goes, well, I changed the pressure stat. It's like, well, how did you diagnose that I changed the pressure stat? Because I changed the fill valve. Well, how did you diagnose because you changed the fill valve? Because I changed the contactor. So at no point, and I bet any of us can tell this story, at no point did he understand how the system actually worked and how the parts actually work. And we've discussed this, all of us have discussed at some point in time, and these are about you guys, about the best troubleshooters I know. What I want to do is go through basics of troubleshooting and theories and concepts that we've all kind of discussed and seen out in the field, and then have the panel add in from their experience. So troubleshooting is done to determine the cause or causes of a problem simply by examining its effects. Rarely does the source of a problem directly present itself, like the example of my fill problem. What it ended up being was the autofill probe was caked up with stuff. So before the tech actually arrived at the autofill probe, he had changed 3 parts and ran 2 hours of labor for the customer. So questions that you want to ask before starting the service is the system new to you? How many times?
No, I was going to say right away, that's my favorite one right there.
Right. It's like, go.
Oh, I was going to say, we're doing the in-shops all the time. It's just people bring in the machines and we start digging into them. And it's like, well, wait a minute. What are we looking for? Well, we don't know. We just bought the machine. And I'm just going, oh my goodness, why didn't you tell me this before you walked away? So it's, they'll drop it off and they don't even know what's going on. They just buy something off Craigslist and bring it in. Or they set it on their counter and like, oh, it's good to go. I'm gonna run my whole coffee shop off a machine I've never touched or never tried. So I had to put that one in right there.
No, that's a good one. What is this unit's history? Can you tell us when it was installed? I mean, is the owner like, well, it was here when I bought the business? Does your company have any historical data surrounding repairs? I mean, how often do we walk into jobs and the barista goes, well, it's broken? And has the system proven itself to be prone to certain types of failure? Do you have similar issues? I had an issue once where the steam boiler kept crashing on a system and the service tech went out there 4 times, but at no time did the service tech think I should check the plug. So it was a power. Rachel's laughing. What are safety concerns before I start troubleshooting? Is there live wires exposed? And then consider the customer and ask yourself, what can I do without causing interruptions to production? Do you really need to take that machine down during a rush and disassemble it? Next slide, Caleb. So the question that I have for the panel is, and we'll start with Mark, is there a benefit to replacing an assembly versus rebuilding it?
Yeah, I think when you're first getting started, we had there was some comments a while back about if you're a newer tech, I think replacing an assembly in the beginning is good for them, mostly because it's they're newly introduced to the customer. It'll be a better customer experience, maybe not price-wise, but as far as being able to get in, get out, get the machine fixed, and then you're able to take that part back that's broken and then go through it with a newer tech to explain to them what's going on, how to fix it. And if that's something you can actually put back in, then you could do that as well. But in the beginning, I do like the fact of just replacing an assembly for a newer tech, so they're not stuck scratching their head trying to go down a rabbit hole to figure out a problem.
Kurt?
I'm going to kind of agree with him to a point on the smaller assemblies. I actually even have my experienced techs just replace some of the smaller parts. Like, I'll just use like can I say a brand?
No,
No. Okay, well, the longer shaft steam wand pieces that just have that one gasket. Well, actually, there are a couple models that do that, but I like to just have them take the whole threaded nut with the gasket and stem and just have them change that one because it's easier, it works better, and it's only a few dollars more. So that's one of the ones I like is if it's only a few dollars more for a customer and it gives it that much more reliability, just replace that assembly versus the rebuild because good chance it might break part of that. So that's another part of benefit I think is the long time cost. You're thinking about whether you're gonna help them or hurt them in the long run. So
Thanks, Kurt. Rachel?
Directly answering the question, a lot of it has to do with the equipment you're working on. Like a lot of super automatics are modular by nature. So if you have the ability to just swap a module and then rebuild it someplace else, that obviously can be better for the customer. Where I'm having not issues, but how does the rebuilding or replacing an assembly directly have to do with troubleshooting and the process of troubleshooting and the philosophy of troubleshooting? Because doing that process helps you determine whether you should rebuild on site or just replace an entire assembly. So can we back up a little on how we got here, or are we proceeding to that?
No, that's a really great call out, Rachel. To the point of the show here is like how do we like wrap our heads around troubleshooting? How's it effective? How do we use it in real life applications? So I think you bring up a great point. And I think maybe so for me, thinking about how I would talk to a customer about what they've experienced over the last few days or weeks, talk to other technicians that maybe have worked on the same piece of equipment, get some feedback there, could lead into that. Have you had, to build on to Kurt's steam valve, have we replaced the sealing gasket a few times and it's leaking again and it's an ongoing problem? Might lead me to replace the whole steam valve instead of the gasket itself. So I think you bring up a great point, and I believe we're going to get into that a little bit more as we move forward in the episode here to sort of wrap our brains around these questions. But that's an awesome call out, Rachel. Thanks. Highland.
Thanks, Caleb. Matt, how about you?
Did you want to expand on that anymore?
Well, I'm thinking about something Rachel said at one of our other meetings about replacing components on a digital board. And remember, Rachel, we were talking about you don't want to replace components on a digital board because you don't know what the rest of the components will be like. I mean, you can replace a capacitor on a timer board, but you don't know how the rest of the system is going to respond to it. So, like, it speaks back to like, is having them replace the assembly troubleshooting, or is it just band-aiding a problem that might be further down the line? It's like, well, I replaced the contactor and that just worked fine. I can tell you about 20 jobs we went back after we replaced the contactor and then the pressure stack fails, or something else along the system. So what's important about what Rachel's saying is you have to check the whole system. Replacing a part really quickly, even in the case of steam valves, isn't really work because like what's in that system is causing it. I mean, replacing a steam valve, well, it's caked it with milk. Well, is there a vacuum leak somewhere? So Caleb, what are your thoughts?
I'm sorry. I think that you're right on, especially around electrical components. That's that's a tricky one all by itself. Do technicians come with the skill set to replace like a capacitor on a board, or is it really a replacement of the whole thing? But I think that's maybe a conversation for another.
It is. It's a good. She made a great point about it, and we actually had a deep discussion about it. Matt, it's your turn.
Yeah, I think it does correlate, and I think there is some measure of techs that are newer or less experienced, I guess I should say, probably might not approach it in a similar vein as somebody who is more experienced. But I think the question has been posed is just that, like, do you know your unit well enough to understand its history? And if you don't, then I think you need to start evaluating the assembly and the parts itself. I think that is part of the troubleshooting. I think you need to not just look at the individual part, but the assembly as a whole. So in general, is there benefit to replacing it and bypassing troubleshooting? I would say no. I think you have to do your due diligence and understand, okay, is this something that overall is me just rebuilding that's going to have long-term impacts for sustainability, or is this something that I'm going to put this in, but there's a good chance I'm going to come back in a few weeks because the rest of the assembly is starting to be impacted directly, kind of like what Caleb was saying with like a steam-related issue or something to that extent. And I think it's kind of front-loaded because I think it also considers the customer's needs as well as downtime as well, which is kind of where it kind of murkies the water a little bit, troubleshooting and understanding the customer's needs all at once. So it's kind of a challenging question to approach, I suppose.
Thank you for the question, Kurt. Or was that you, Matt?
I think it was me.
Okay, next slide. It's a good question. Next slide. So where do you start? First is understanding what a properly operating machine part does. This helps diagnose the problem. Well, I mean, Rich Leeson said this once, it's great that you know how to test a part, but you understand how the part actually works. And that's the key difference, I think, is, you can test a solenoid, ohm it out, or you can understand how a solenoid works and see what's happening. Make sure that you have the right tools. Get a complete and accurate description of the symptom when you arrive to the site. All of us know this, and I have done this myself. The machine's not working. I have no steam, but my bar pressure is 9. So if my bar pressure is 9, why do I not have steam? And reproduce and confirm the symptom. It's not always clarified when your dispatcher tells you what it is. Narrow it down to the root cause, and then call for help if you need it. I don't know if you guys have experienced, but I have some techs in my system that will spend 2 hours on a system where it's like, call somebody for help if you can't figure it out in 1 hour. I mean, we have a rule in our system where if it's 1 hour, you have to call somebody.
You're nicer than I am on that one, Highland.
I am.
I actually say half an hour.
Really?
If you're still staring at a machine for a half an hour, then you need help. And I'm going to call you out on that one, because within half an hour, I mean, you open the machine in 2 minutes? And if you can't go to the certain part you need within a half an hour, you really are kind of taking your time and struggling, I think.
What do you guys think?
I think 30 minutes is good. We do 15 to 30. Make sure you have an understanding of where you need to go. You're not just, like Kurt said, staring at it. We've had, unfortunately, techs that have been there for 90 minutes, and you ask them what's going on. They're like, I haven't figured it out yet. And, if I had any hair, I'd pull it out. But you just go, would you just please call me? And I'll, we're all here to help. We have plenty of experience. So, I think that, 15, 30 minutes, that's probably a good indication. I think an hour is too long, Highland, just because, again, like Kurt said, if you don't at least have a direction to go within 30 minutes, you're in the weeds already.
Rachel, thoughts?
That one's kind of difficult because, especially since, we're here at Troubleshooting 101. So finding a balance between encouraging somebody, including yourself, to look at your resources and figure it out yourself, and then balance that between where you're stuck. I know from my experience, especially with dealing with new equipment that I'd never seen before, or do this preventative maintenance on this machine you've never seen before. Just go do it. Is it helpful for me to immediately just go, hey, let me call somebody and let them tell me it, or take the time to do my own research, look at the parts catalog, look at the system? It's kind of difficult to judge what time is too much before you reach out to somebody. And I'm coming from a perspective where oftentimes one of the most common calls that comes into me currently and from my previous position was, I haven't been to the store. I don't know what's going on. My favorite call was, I haven't been to the store. It's an hour away. All they told me was the machine turned off and won't turn back on. I want you to tell me what is wrong with that machine and all the parts I need to take with me to fix it. And what are you supposed to do with that? So it's finding a balance. Does come with experience, but knowing what that time to cut it off, to allow somebody to figure it out themselves, versus, and I understand a lot of my experience comes from being an internal tech with Starbucks, where I was a paid hourly employee, so there wasn't that charge back to the customer, where they were carrying the burden of me learning on site. And so I understand that, like, that's complex, whether you're internal, external, how much experience you have, and how to mentor a new person who's approaching this. Where do you cut it off? It's a difficult position to be in.
Yeah, I think experience level falls into that too. And if you've ever seen that piece of equipment that you're standing in front of before. So there's a learning curve, right? Maybe like there's a sliding scale there. I hear what you guys are saying, 30 minutes an hour, like you've got rolling techs out there that you know what they're capable of, and you want them, like, to, if they're stuck, you want them to call and get some help. But then what Rachel's saying is, there's times where you're a green bean and you're trying to figure something out. You might need a little bit longer. Thanks for that, Rachel. Matt?
Yeah, I think there's situations too where, like, you might have a lot of things you have to cross off. Let's say like it's a water related issue and you're having some flow things that are going on. Like, you might check internal like flow diagrams and check the entire path of the waterway and make sure it's clear. And then you might be like, okay, well, maybe there's something going on with, the back of house RO system or something with the water filtration. So back and check that, and you're not 100% sure, so you pull out like an inline gauge and check your water. Like, those things kind of take time, just to be able to filter through, make sure all your valves work, and make sure your water paths are clear. So I think there are instances where it might take longer, but I think it's tough to, like Rachel was saying, I think it's situational. It might take an hour to properly diagnose some of those more complex issues, and sometimes it's simple, and you probably just need to make a phone call. So.
Thanks, you guys. Next steps are repair or replace the defective component, test, and then test again. And what I meant to put on test again was test again with the staff member or the owner who's there. Show them what the problem is, and then give them a concise description of the actual failure and the problem, and let them know that there's any issues that you noticed. More times than not, you're going to be in that machine, you're going to see melted wires or components about to fail. So it's important that you actually communicate to the customer what's going on. Caleb, next slide.
Sure, and I want to mention now as we move into this next slide, if anybody in the audience has any questions, go ahead and throw them in the questions box, and we'll ask those questions to the panel sort of as we go.
So 2 questions that I get asked. Sorry. Kayla, can you read those, please?
The question?
My voice is going.
Oh, you want me to read yeah. Do I need to understand coffee espresso quality to troubleshoot? Do I really need to understand water quality?
Let's start with Matt.
Well, I'll go ahead and take the top one there. Yes, if you don't understand the process of what coffee should look like, what it should taste like, you're highly handicapped going into this process. I mean, you can take visual cues in and of itself and understand how something is pouring. And, you know, if you understand extraction and how that works, and you understand how a flow through, you know, an espresso puck looks, you have a really good visual understanding of what you're looking at to begin with. So if you don't have that, you're taking part of your natural ability as a troubleshooting technician and throwing it away. And it's extremely challenging to understand why something is happening if you don't understand what the process is to begin with. So I would say, yeah, I think it's absolutely necessary to understand coffee, at least to some extent, even if you don't like it. I think you have to understand, you know, the process of what's happening.
Thanks. I know it sounds like a really standard question, but as somebody who runs into third party, manages third parties at the level that I do, I can't tell you how many times I run into a tech that says, I've never made a shot of espresso before, or I don't drink coffee. Rachel, what do you think?
We're fixing coffee equipment. So part of our job is to understand coffee and how it's made. And as far as the troubleshooting process, gathering information, if a barista is saying, well, my shots taste sour, what does that actually mean as far as extraction? I'm not getting any crema. What does that mean as far as what the machine is doing or not doing that's not giving that? You know, we should all know heat, pressure, and water quality, dosing. That's all part of what makes a shot of espresso, or even with batch coffee. So not knowing that is going to extremely limit your ability to narrow down what the problem is in a more timely fashion. If you think, well, I'm used to this and it tastes fine to me, that's not doing your job and doing your due diligence or listening to your customer and what they're wanting or needing. You know, water quality is certainly a huge part of that, and that's the one thing our industry is really struggling with, is understanding water quality. When that has everything to do with extraction and the flavor that you're getting from the end product, as well as the health of your equipment.
Thanks, Rachel. Kurt, Mark, do you guys have anything to add?
Oh yeah.
No, Wes.
So I want to actually go over the coffee one, just kind of start. So building off what Rachel was saying about batch brewers, if you don't know what the coffee is supposed to taste like, you can't just go, well, I've got hot water coming out, because what if the water's too hot? What if the water's too cold? But if you don't also understand what it's supposed to taste like, you can't actually be able to figure out and go, well, it's not the brewer that's the problem, it's my grinder that's the problem. So you do have to understand coffee and understand that you have to actually be able to separate those two machines and figure out which one is really the problem for the customer on that. And the espresso is just way too much. You just have, if you don't understand a shot of espresso, and especially coming from being in elevation up in Denver, if we don't turn our temperatures down here, we get a dead shot every single time. I can't tell you how many people get the machines directly from a manufacturer and they're set for sea level. And they try and, oh, well, I'm getting dead shots right away, dead shots right away. Bring your temperature down. We can't brew at the same temperature as anywhere else. So yeah, if you don't understand the coffee, you can't separate the machines. And if you don't understand the espresso, you can't figure out what is the true reason, because it may not even be part of the machine. It just may be part of the process. So that's what I wanted to add.
That was good. Mark, how about you?
I'm going to agree with Rachel on water quality, water understanding. Every time Scott Manley does an hour-long presentation, I realize I know even less than I did before the presentation, because it's so complicated. I mean, with water quality, I mean, we really are just, we just have the tools and can get the numbers, and that's as far as I really expect my guys to go. I mean, if the water tastes funny, we can work with that from there, but that's more of a team effort. They'll reach out for help on that. As far as understanding, that question is really too complicated to answer. If you understand espresso quality, it's, we're kind of going back and forth to, can you taste the difference in, a good espresso shot or a bad espresso shot? Do you have that kind of palate, if you will? I have 3 or 4 techs that don't drink coffee, and I think they do quite well, because we are fixing equipment. We know the process of how it works. As long as we understand that process, to what Highland had said, when you finish your call, it's not done till the customer gives you the thumbs up. And that part of that is they taste the product. They make sure that the taste, because, they're the experts. I'm certainly no coffee tasting expert and don't claim to be, but, if you had somebody in there that, a roaster that, really knew coffee and could really, articulate it down, they're not the expert in the store. It's the person that called it in. It's the person that drinks it every day. They've noticed something different. It's them that has to be happy with the quality of the coffee. And to Kurt's point, yeah, it could be, they changed the batch, the batch size of how much coffee they're putting in, or the grinder is out of adjustment, and we can only go by what they say, because, again, I have a few techs that don't really drink coffee. They can say, well, it tastes like coffee. But it's really the customer that we lean on at that point to say, tell me why it doesn't taste good. And then really getting to troubleshooting, to Rachel's point, part of the troubleshoot is understanding, the first thing is ask them what changed. Something changed. Do you have a new staff member? Did you have, do you have new coffee? Did your water system just get recently serviced? Has your, there was a storm last night? It really is part of troubleshooting is, go in first and say, what's different from yesterday to today, when the problem occurred.
Yeah,
Thanks,
I
Mark.
totally agree with you. I think it really changes your approach. I think if you don't like coffee, you still need to know a little bit about how the process works to fully be able to service something. But I don't think you have to enjoy it to be a competent technician. I think it changes your approach as to, like, are you going to go in and look at shots in the quality that's coming out, or are you going to look at the more mechanical process as to what your water flow is and check, your volume and all these other things. I think it's just a matter of adjusting your approach to what your knowledge base is, and it just might look different. So yeah, great points.
Caleb, anything to add before we move on?
No, I think these are all really relevant points, and as far as troubleshooting goes, these are some of these things you learn along the way, some of them you bring with you, right? And it's incorporating these things as you go, because, I mean, gosh, how would I have known that a rainstorm was going to increase the overall TDS by 1,000, one day to the next? I mean, how am I supposed to know that? I mean, I know how coffee works really well, but how the municipalities treat their water from one place to the next, I think that's something that as a local tech, you have the opportunity to at least get close to it there and understand what happens in your space. And then you can use that in your day-to-day life. Like Rachel's trying to help troubleshoot across the country or maybe across the globe. I'm not sure. And that's going to change how she looks at water in a really dramatic way, and how you might help people in that moment. So then helping them learn the tools and how to use those tools to better inform their next steps. I do want to say we're a little over the halfway mark. We've got a few questions, and I want to make sure we save time for that. So I think we'll move on to the next line if that's okay with you, Highland.
Yeah.
Did it move on?
Calling tech support.
Good.
This is a quick one.
Sorry.
I have issues, and I chose to put this in because I can't tell you the number of techs I call who it's a point of pride to not calling tech support. And this goes back to the comment about how long should a tech be on site. As tech support, when you're calling tech support, they can't read your mind. It's up to you to tell the tech support person on your situation needs. And again, I've had this happen to techs that call in. It's like, my machine's not working. It's like, you're a tech. You need to be specific as to what's happening. And you want to make sure you get the right person on the phone. There's so many tech support people you call, they're looking at a decision tree. It's like, and asking them, do you understand this machine versus, well, you pressed button A, the next line is you need to press button B. And you have an idea of what you want to get from the conversation. What do you want to know about this machine as you're working on it? Have a concise description of the actual failure and the problem and the question, and make sure that the phone, and Rachel captured this really well, make sure that the phone and the equipment is in the same room. And then make sure when you're seeking support help that you properly ID the machine or part for the best support results. Because I've had this happen where it's like, well, I'm working on a coffee machine. Well, we're going to recommend a fill valve. Then you get a fill valve for an entirely different machine. So it's just, as your calling tech support is a key component of troubleshooting, and get past the, I don't want to call tech support because, and I've had this happen. I've had a customer say, well, your tech wasn't trained because he called tech support while he was on site.
Let me make a comment on this real quick.
Kurt has a comment.
So one of my favorite things I always point out to trainees, it's called tech support. It's not called consumer support. This is meant for us, the techs, to actually call. I mean, if a consumer that would call Rachel and say, well, I have this problem, and she's like, okay, well, pull out a meter. And like, I don't have a meter. She's going to say, okay, you're calling the wrong person. She's there for the techs. She's there for us. She's not there for the consumers. So I make sure that's very, very clear that the tech support is for you, the tech, and that's what they're there for. And it doesn't actually even have to be the manufacturers. You can call your coworkers and whatnot, and their tech support also for you. So people need to get over that. Well, I'm a tech. Well, yeah, but you do have limits, and make sure you know where they're at and when to get help.
I'm here for everybody. That's a cafe owner, a home user, somebody who is an investor and is calling because their investment is down, and technicians, including green and experience. My job at La Mazzocco is I am here to support everybody with their technical needs. I do appreciate some of these, I'll call them call outs though, especially with having your tools when you are a tech and calling support, being in front of the machine as much as possible you can, knowing what machine you're working on. And all of us are only as good as the information that we are provided. I am not a mind reader. I can't, through the phone, tell you where a steam leak is. I cannot, through the phone, tell you where a noise is coming from inside your machine, especially when you don't take panels off. I can't tell you what's leaking if you don't take panels off. So there's an investment that comes into troubleshooting and utilizing part of your troubleshooting with calling for support. I also have to exercise troubleshooting skills on gathering all the information I can, which does include to circumstances, are there new people? And does somebody have an appropriate tool or a meter, and is the meter working? There's so much that goes into that, and it's a mutual relationship with calling for support. But it's I'm not here to solve your problem. I'm here to help you solve the problem. And that's something that sometimes, especially when you're in a situation where you've been there for hours, you kind of forget that. And yeah.
Matt?
I had a great sentence there too, and I was on mute. Matt, Mark, you guys want to say anything before we move on?
I'm good right now.
I think Rachel's right. I mean, I always tell my techs that, tech support's a tool. They talk to a lot of people. We don't want to waste their time, so we try to give them as much information. But I always tell them tech support's not there to do your job. They're there if you have a legitimate question. Like if you don't understand something, in 3 minutes, Rachel can probably answer your question and you can move on and she can move on. So, we try to utilize tech support as more of a tool type situation and try to appreciate their time they're giving us as opposed to not wasting it.
Thanks. Hey, Caleb, do you want to ask Scott Crispo's question, his third question, because it's kind of a good question to ask.
How long should we wait for tech support to call back? I had to wait.
I feel attacked by that, Scott. Thank you.
I had to wait hours and been on to the next job. Yeah, I've experienced that.
That's a real problem now with COVID and just the number of calls that, I know Kurt's probably had the same thing and probably Matt, and well, you've all experienced it. Just the volume of calls has skyrocketed right now, and so everybody's calling. We have 2 particular manufacturers that sometimes it'll be a day before they can get back with us, and we have to move on. And it's just something that right now we have to deal with. Because you can only, Rachel can only talk to so many people a day.
Yeah.
I also want to add to that is there's more ways to contact a manufacturer than just calling. So email and calling can oftentimes get you quicker results than by simply calling. And also leave a voicemail. If you have the opportunity to leave a voicemail, do it. Because if we're on the phone and you call through and don't leave a voicemail, you move on to the next voicemail.
Yeah.
No, it's a fair comment. They don't know you're calling for troubleshooting if you don't leave a message.
Right.
And I was going to say real quick, you guys say the email and the phone calls. There's a lot of manufacturers, if you're part of their service group, know that a lot of them may have a service channel or a web channel that you can get on and talk to a lot of people. So make sure you know all the ways that you can call out and get your support.
Yeah, that's what I was going to say too, Kurt, is know your other options. Have a list of options in your tool bag for support, because for instance, I get calls from unknown numbers all the time, and I never know if they're robocalls or not. And sometimes I'm not able to take every single mysterious phone number just because of the nature of my job. And so we have 3 designated tech support people that work for us as well. And if you don't know that you can reach out to them in addition to me, you might be sitting there waiting for me to call you back when you did leave me a voicemail. So just know your backup options and have point A, B, and C that you're getting ready to call if A doesn't pick up.
Hey, I'll just add one last thing. When you're talking about, Kurt was talking about, utilize all your resources, and so was Matt. It's a plug to the CTG. That Slack channel, it saved me many a times on there when I've had a question, been stumped on something. I'll put something on the CTG Slack channel and I'll get an answer back pretty quick.
We try our best.
Yeah.
Let's move on to the next slide. So this was a slide provided by Rich Leeson from Bunn, and I thought it was actually made some interesting points. Is understanding the component process. The machines may have the following processes with a series of parts that provide that function and process. And this goes back to my story about the fill system. Is that it can be a component of a fill system, a heating component, or a brewing component. But what I find is techs will look all over the place to try and solve a problem when a pressure problem is the pressure system. And he made an interesting point that there's no need to repair or replace parts that have nothing to do with the core issue. And that's really common, goes back to my initial story. Let's move to the next slide.
Actually, I think this is a great spot to add in. Coral Pope asks, how have error codes changed how you troubleshoot? Who would like to take that one?
I'll just give a quick little answer. I just use them for a starting point. And
Yeah.
error code may just give me an idea of what, especially on the super automatics, just what module to start with. And that's about it. I don't really use them for much else. I don't go, oh, that error code tells me to replace this part. No, it just tells me what circuit I'm probably looking at is all I think of it for.
Gives you some direction.
I would say it depends on how complex the error code is too. You know, some units will have more definition attached to each error code, and if that helps you find a little bit more, it gives you more context clues. You know, use it to your best, like Bert was saying, as a hint as to where you're going. It may help ease your process. At the same time, it can be complex too, because if you have a 24-volt circuit and it's telling you, oh, there's this issue over here, and it's really not that issue, it's something else in that 24-volt circuit, it can be really confusing too. So on one hand, it can be super helpful, but unless you know some of the weird oddities, the outliers, it can be confusing at times as well.
Thank you, guys. Caleb, let's move on to the next slide. So what we did here was we put together a list of troubleshooting tips that for our viewers, if you'd like a copy of the PowerPoint, take a look at it and feel free and email us at the Guild, and we'll send you a copy of the presentation. And does anybody have anything to add to this before we move on to the final two questions?
Yes.
Oh.
Troubleshooting tips. So there's something called the KISS principle. It's from the US Navy in the 60s, and it stands for keep it simple, stupid. As humans, we like to overcomplicate things, like jumping to the board every time if there's an issue, rather than stepping back and starting from the front. Like somebody had mentioned, nobody starts with the plug. So starting at the beginning, and error codes are great to kind of move along farther in the system, but it always comes back to keep it simple. Start at the beginning. Don't overcomplicate things. Start, do you have power? Is there an issue with the breaker? Is there an issue with the outlet plug? Is it on the right kind of circuit? Starting there will get you your resolution faster than just jumping ahead to something. Because what oftentimes happens with jumping ahead is you start to replace parts. That doesn't work. You replace more parts, that doesn't work. The machine's down longer. The customer's frustrated, you're frustrated, and you've spent a lot of money that didn't need to be spent. So keep it simple, stupid. Don't be just a parts changer. That never ends well in the long run.
That's a great point, Rachel. Thank you.
I think I'd like to echo that a little bit and say, you know, there's a start and an end, right? And that's an electrical system or a water system. So what maybe you know decide which one you're trying to approach, and then I found that sometimes starting at the end and working my way back might be better depending on what the problem looks like. But either way, just make your way through the system. You will find the problem if you're diligent. So from the receptacle, the cord cap, you know, to the outlet valve, or from the supply valve at the wall or the filtration system, all the way through to the cup. And I'll just leave it at that since we.
That's a good point, Caleb.
I
Anybody
want to
else?
throw one other saying out there that I just recently learned. This is especially with repair and troubleshooting. It's good. Take the time it needs so it takes less time.
Yeah, for sure.
Great one, Rachel.
Very
Great one,
wise.
actually. That is very, very wise of you. Okay, anybody have to add before we move on to the final two questions? Okay, Caleb, go for it. Oh, finishing the service. I forgot. I had one on finishing the service. Inform the store of the symptoms and the outcomes. And this is really important because if the store has a callback, you want to make sure they know what's going on and that it's been clearly explained to them that the issue is what the issue is and what's causing it. Matt made a really good point about, is this something I can use as a teaching moment for the store? So like I have a lot of techs that are trained to teach you how to use a steam wand because steam wands are number 4 on my service issue, and how to adjust your grinder. And are there underlying issues that need to be resolved by another contractor? A lot of us see this where you go in and the water's an issue or the electrical issue, and that you need to make sure that, and it gets, the tech will forget it. Hey, you need an electrician and walk away. So you want to say you need an electrician to do this, 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 and this, or you need a plumber to do this, 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 and this. So the system gets repaired so you can either finish the repair or the customer's not down again. Any questions on that, you guys? Comments? Okay, let's move to the last 2 questions.
Yeah.
Three questions, actually. You have a personal example of how you may have missed an issue by not asking questions or bypassing typical troubleshooting steps. Let's start with Kurt.
Actually, I'll use one of my favorite things. NCV on the meter, non-contact voltage. And I've seen this and I'm guilty of it where I was like, well, here, let me just hit something right there and see if I'm getting voltage to the part. Oh, I'm getting voltage. But I forget that when I'm on anything European, they're breaking the neutral or negative, whichever you want to call. And so there's power to the part. Where, you know, if it's something built US, typically you're breaking the power side first. So it's always like, that's my favorite one. I'm always like, hey, people recognize, or I use that to tell my guys, make sure you know what you're working on. Make sure you know if it's what side of the voltage line is being broken.
Thank you, sir. Rachel?
Highland, let's move through these questions. That way we can get to the attendees.
Rachel, let's go question number 2 for you. What would you say makes you so proficient at troubleshooting?
I listen to a lot of the people who have more experience than I do. And I've learned a lot that has helped me become better at troubleshooting. So listening to those who have came before me and remembering what they have said, including remembering my past mistakes that I've made, so I can move forward to using that information to be better going forward.
Thank you. Matt, this is a good question for you, is what do you find are some of the most challenging items to troubleshoot, and how do you train your teams to approach those?
Yeah, I think electrical can be really tricky. If you don't have any understanding like of the basics of electricity, like if you heard Kurt talking about a neutral and you're like, what's a neutral? There's a good chance that electrical is going to really throw you for a loop, you know, and I think we've really tried to get our techs to be proficient at that and have a great understanding of those electrical issues. Because even if you don't understand the mechanical side of things and how electrical like impacts those things, like it gets really complex real fast. So if you can do simple electrical tests with your meter, you know, add a chassis connection, let's say you're working on a modular system and you can take, and you know you should be getting voltage there, like it starts to really reduce the location and you can start to isolate where those issues are. So I would say for us, electrical is big, and that rolls in a whole bunch of computer related items as well, because it's all kind of interwound. But you know, go through some free classes if you're not there yet. You know, take some Fluke related coursework, and you know, at least to get yourself to a place where you understand you know, what amperage is, you know, what voltage is, current, all these things, and that'll really help you understand kind of what is happening with the system.
Thanks, Matt.
I'm
Mark,
gonna go ahead and hit up some of these questions. I'm gonna ask Kurt first. Question came in from Scott. Chris, would you discount labor if a green tech took longer than you think an experienced tech would take?
I've done it multiple times.
It seems like the right thing to do, right?
It is, and I try to make sure I take care of my customers. That's the biggest thing for me is, I mean, if they're not there, I don't have a job, which means I don't employ people. So I make sure I try and take care of them as best as I can also.
Mark, can you add to that at all?
What was the question again, Caleb? I'm sorry.
If you had a green tech that was taking longer than they really should just because they're learning, would you, you know, reduce the charge, I guess, for the customer?
Yeah, just like Kurt. Yeah, just like Kurt, we have. I mean, when you're a business owner, you have to look at, you know, is it worth it to, you know, it's you want that customer long term. You're not going to ding them for a couple hours and lose it. You want to, and you know, if you care about the customer, yeah, you certainly make adjustments for that too. And you also let them know that as well, that they're, you know, your tech was, you know, doing a little bit of learning on there, and you know, we're not going to make you pay for that, but you know, this helped everybody.
Great. So I've got another one from Ron Bilo, and I think I'm going to give this one to Rachel. What's your decision tree for a blown boiler safety valve? Same question for overly fluctuating boiler temperatures. And you got a couple. We got about 3 minutes.
Hey, and Rachel, he's not at the store and he doesn't have any tools.
And it was a friend he's asking for. So he's never even seen the machine.
Of course. So pressure relief valve, it's a safety device. It releases once the boiler pressure reaches that pressure. So is the boiler overheating or has that part failed? And then more than likely the boiler's overheating, so you test that circuit, which means starting with testing the health of the element with your meter, and then going back to the other components that are responsible for sending power to that element. Are they working or not? And again, that is with meter and also visual inspection. If you see a wire is all crispy, that might give you an indication of where to start with the troubleshooting process. Also checking ground. I've had so many steam boilers overheat where there was a loose wire in the cord cap for ground.
So there's your boilerplate answer. I'm sure there's a ton of other things in that space around how, you know, overpressure valve might pop off, but that kind of hits it. So I want to say thanks to everybody. We are at the end of our time now. We've got about 1 more minute. Anything anybody else would like to add to the conversation as we depart?
Thanks, you guys, for your input. It was really appreciated, and thanks for the solid work. I appreciate it.
Yeah.
Oh, and awesome. Have a great weekend.
Yeah, awesome job. And Rachel, way to keep us focused on troubleshooting. You were really helpful here, because we'll just talk about, you know, we'll share our stories all day long on this space, and we really need to make sure that we provide some good insights outside of that. So thanks to everybody that showed up, and we'll see you guys next Friday.
Bye.
Thanks. Bye, everyone.
Bye-bye.